All right, so we are streaming some Try Hack Me, Advent of Cyber. Let's see, where did our Cali box go? Okay. Let's get set up and read the challenge. So what do we have? It says someone stole Santa's gift. This is day 5, task 10. Let's go ahead and get deployed. Hopefully. Oh, and we're also not connected, so we'll run through the connect script real quick. So connecting to Try Hack Me's VPN network. Pretty straightforward. Now we just kind of leave this window open. Okay, so I'm going to copy this. It says, let's refresh. Uh-oh. Dashboard. Advent of Cyber. Okay. So it says after the last user tag, worked hard reviving Santa's portal. Hence Santa's Form 2 went live for the attack. So let's go ahead and get it deployed. Doing so, we're able to dump the whole gift list database, getting 2020 gifts in their hands. And attackers threatened to publish the wishlist.txt file containing all the information. But happily for us, he was caught by the CBI, Christmas Bureau of Investigation. Okay, you'll find a copy of the website at our goal to replicate the attacker's actions by dumping the gift list. Okay. So this seems like it says it's another web exploitation. They're calling out SQL injection as the vector. And I think they're going to, here in a second, it's going to show us this IP address. This will get updated to whatever is appropriate. But it's, never terrible idea to sort of see what all's on that IP address. So we just run a quick nmap. We'll just do everything. It'll be a 10 dot something, most likely. There we go. Not right here. So let it run. I mean, they're telling us it's on this. This is the web application. Copy. Let's just open it up in Firefox, Kali. It says, here's Santa's official forum. Welcome, stranger. It's a place to exchange your yada. Huh. Struggling to choose a gift for themselves. What happens when I click stuff? Nothing, I guess. Just looks good, though. These comments, V2, Santa's forum is back. All right, and so what's really cool about this Advent of Cyber is that they have a lot of like exposition about the task, the thing that you're supposed to be learning, and a little bit of like filler information, just enough information to sort of get you started. Let's see. As you can see, that marks yada. And they're just kind of explaining the fundamentals of SQL injection, which is really cool. All right. So what's like super important about SQL injections, we have to find out what is the attack surface, like where are we controlling input as a user. So I'm just kind of clicking around. I don't see anything. Welcome back, strangers. A place to exchange your Christmas wishes. Popular topics. Source, anything in there? Skills and interests, achievements. So normally, like you're looking for something you can manipulate in the URL bar. You can look at something, I don't know, a link that you would be clicking or an input field in particular. It says welcome stranger. This is a place. So like let's maybe guess some stuff. Is there a login? No. Index.php. Robots.txt. No. So where are they guiding us? Fine. So first we have to find the secret login panel and then bypass the login. That's the challenge. And then we have to answer these questions. So without using directory brute forcing, what is Secret Santa's login panel? Okay. Without using directory brute forcing. So that's the puzzle. What did we miss in here? It should be something, in my mind, it should be somewhat obvious. Static, login, secret. So in my mind, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 10. Santa login. I don't know. So this is where you always fall flat on your face. It's like we're supposed to be on here hacking stuff, but we can't even get to the challenge. Okay. Bypass. Secret login panel. Login panel. Did I try that? Forum login. There. Login. says without using Fox. B2. Is there anything else in the challenge that I missed? All right, so no shame in asking. Santa panel, that's what I tried. Is it not? S-A-N-T panel, Santa panel, that's what I did. But obviously it didn't work, so huh. Okay, well, we're in. Let's see. So, I mean, always throw in just a single tick just to see what happens. It says internal server error. That's likely not what we're supposed to get. I type in ASDF, log in. Greetings, stranger. You're not a member. Okay. So they reference burp a lot up there. So let's try this real quick. So I'm going to do this. The classic, SQL injection. Oops. Off, back. Again. Recent. Oh, all right. Well, that wasn't a great demonstration. Let's go back, I guess. So I go forward to Santa panel, delete my cookies, I guess. So let's see, what did it do? Storage. Yeah, so I'm going to delete all. And the next time I log back in, they'll say, oh, you're not logged in. So what I typed was the classic SQL injection thing, no password, log in. And the reason it freaked out was because I told it to go to my Burp Suite proxy, which I did not have running, which I should probably go ahead and do. Close that. Next. I can go ahead and run everything through the proxy so that if I want to start monitoring stuff, it won't be an issue. So I go to proxy, I'm going to turn it off. All right, so the database has been updated while you were away. So first of all, let's get our points real quick. So that was /Santa panel. We got that correct. All right, and then entries are there in the gift database? How many were there? 1, 2, 3, 4, 0, 4. Oh, hold on. Let's see. Gift NULL. Null. Oh, interesting. Child. Huh. So what happens here? I want to search for toy. Toy car goes to Charles. How much by throwing a tick? Unrecognized error in the gift. Unrecognized token that. Okay. Interesting. Okay, so this dumps the entire, some parts of the entire database, I guess. So if we go back and look at the explanation of kind of like how the SQL injection works, I think they always have, and I try to always show off a string that looks remarkably similar to this. And so what they're their SQL in their database looks something like this setup right here. So we're selecting, and in our database here, it's like gift and then toy or child from, wish list, where, search query, open quote, and then this is like the variable input that we control, right? So this is a variable in PHP or some other language, Python or something, but they're not using a prepared query or prepared statement. And they're just kind of directly interpolating the value of that variable into the string. And so if that variable includes the same kind of quote that they're using, the parser for the language or for the SQL server won't know the difference between this quote and a quote that I, the attacker, have put in to the string. It can't know which one is valid or invalid. So it reads it just like you would read it, top to bottom, left to right. And so it hits this quote, the quote that I witnessed, and then I told it in my content, I told it tick, and then these two dashes are the comments as they're kind of going through with all the SQL injection. Like if you follow through right here, you'll kind of see some more exposition about what that is. Once it hits a comment, it ignores everything to the right of the comment. So it's basically, in this instance, it's going to say where our query is like the empty string, and everything is likely to encounter that. And we'll look at some maybe search queries in a second to sort of help illustrate that point. Let's see. Oh, I got to get out of here. There we go. But because searching is a little bit different than like validating a password because you're using wildcard characters most likely. So let's see. So it's asking, one of the questions on the Try Hack Me admin thing was how many items are in the database. All right, so in the gift database. I'm assuming this is the gift database. I don't know that to be true, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I see 22. That's my guess. Let's see if we got it right. Yes, we got it right. It says bypass the login, use SQL injection. We did that. Didn't need to give it an answer. What did Paul ask for as further evidence, I guess? Who is Paul? Paul asked for GitHub ownership. Okay. What is the flag? Oh, all right. I didn't see a flag in there anywhere. So we might have to poke around and see what else is in the database. So there was a tool that they referenced called SQL Map. SQL Map is just a way to automate all the trial and error that is often required when like hacking a database by hand. So let's see. I don't know if we can do that work. Yeah. All right. So like I just did what they call a union query. So it basically takes the output of one query, aligns it to the output of a second, what they call like subquery. And as long as the rows and columns align, it will show me the intersection of those two sets of data where they map one to the other. So what I did was basically, again, I'm allowed to now see additional input from the database. I can make an arbitrary query. So I don't have to, I select 1 and 2. Those are just kind of like scalar values within the database, I believe. Just like basic numbers. I'm saying the number 1 and the number 2. Show
the number 1 and the number 2 alongside the other data in the database. So it asked, one of the questions was asking for username and password. So I'm going to guess username, password from users. And again, I'm making a bunch of assumptions here that username is a valid column name and the password is also a valid column name. And that there's an entire table that is called users. And both of those columns will exist in that table user. So let's see if that was a reasonable guess. Seems like it was not unreasonable. So let's see. It's at, what was the question again? It asked for, what is the admin's password? That's what it was right here. Copy. Where's my scoreboard? Here. Admin's password. Paste it. All right. It appears that we got it correct. Okay. So now it's asking for the flag. So we have to find the flag somewhere. Don't know how to do that. I guess we can look at the SQL map tool real quick. All right, so this is like super good indicator of like how to start attacking something like this. Anytime you can feed input to a URL like this, it's rife for, you know, sort of abuse because you can really easily automate that. So there's a tool in Kali Linux and just on computers called SQL Map. Let's see. All right, so you can start it by just typing SQL map, and I think they give you a really good walkthrough in here. So let's go ahead and just follow that walkthrough. Now that I think about it, that way I'm not having to do a lot from memory with it. Open source penetration testing tool that automates the process of detecting and exploiting SQL injection flaws. So what we just looked at was a SQL injection flaw. We were able to inject the structured query language into some other programming language. We were able to manipulate that by abusing the input that we're allowed to control as the user of a system. So what does it say here? It says the most common options you would use. So we have to provide a URL. That's because that's what SQL map is going to attack. We can give it a hint as to what database it's running. Otherwise, it has to try to guess the database because there's many databases. There's MySQL, Postgres, Access, or well, Access technically, SQL Server from Microsoft, SQLite for standalone stuff. So you can dump the database. You can dump the entire database. I think dump will give you just like the top like 100 rows or 20 rows or something from every table, whereas dump all gives you every row that exists. So let's see. We have a vulnerable form located here. This is just an example. This is an interesting point. I'm glad that they go through this in all of the Advent of Cyber like walkthroughs. This is just an example. Do not use SQL map. This website has no consent has been given by the owner. Consent is very important, right? You don't hack things that don't belong to you without explicit permission. So because we're on this website and this platform, there's a permission that's been given to us to do this. So what does it say? SQL map. We need to give it a URL, which is right here. And I think we hit enter. What happens? It says testing the target URL. All right, so a bunch of stuff's kind of scrolling through here. Let's zoom in on this. So as we feed it this information here, it's going to run a bunch of commands, and you can see here that's checking If there's some sort of web application firewall or intrusion protection system sort of that's filtering communication with the actual application. And you can see here, testing if the target URL content is stable. It's checking to see if any of this stuff is dynamic or sort of random in nature. Testing to see if the parameter search is dynamic. It was able to detect that this is what they call a get parameter, meaning it shows up in the URL itself. This is the thing that we're saying is vulnerable. So you can see here, it's trying a bunch of things, basically to sort of see if it can determine whether or not it's Postgres, Microsoft, SQL, MySQL, or some other database. Okay, so what did it say here? Did not appear to be injectable. Well, we know that's not true because we messed with it. Space to comment. All right, so all test parameters do not appear to be increased the values for this. We want to perform a test. We suspect that there's some kind of mechanism involved. You can maybe try the option tamper, e.g. tamper space to comment. I guess I don't really understand what that means. I saw it in their walkthrough. So they also fired up Burp Suite and were able to intercept the request. So let's do this. Oh, okay. And don't forget that you installed a web application firewall last year's attack, so you forgot the command. Okay. So let's see what that does for us. Okay, well, now we're getting slightly different results, I think. All right, so here's the first prompt that SQL map has given us. It says it is recommended to perform on the basic union test. Do you want to reduce the number of requests? You can just hit enter, I guess. I don't know. It says yes is the default, so why not? Ah. No. Let's see. What else is it telling us? Bypassing space to comment. Okay. Well, I don't really know what that is. And that's the whole point of the challenge. We got to get that. So, all right. Well, let's try that manual enumeration. So I'm going to come back over here, back into our thing. We can do this, and we know that we can run arbitrary commands. There are some commands, and I think they call them out at, is it DB version? Am I wrong about that? I think they show you one of those things at version. So this will help us. Okay. So select. And this is just the boring part of hacking. Just kind of sitting and thinking about what could this be. So I'm going to say select 1, 2 from flag. I'm going to guess if there's a table named flag. No such table flag. Right. 1, oh, well, actually, they have a great resource for us right here. Payload all the things. Let's look at that. So there's tons of resources out here, and this is one of them. The community kind of makes all of these things sort of show up. So what I'm trying to do is maybe list out list out the tables. Tables. Like at version 2. Did I do that? It said unrecognizable character. So let me put that back real quick. At version 2. It says unrecognized token. I'm going to search to see what does the internet say that this is. All right, so I Googled this error message because I figure that's coming from the program itself. And the first thing I see is SQLite, unrecognizable token exception, yada, yada. I see a bunch of SQLite stuff referenced. And it stands to reason that they would use SQLite because you don't have to have a whole separate server set up to store your database stuff. It's just the SQLite file itself. So SQLite it's a database that is just kind of like a text file, in the sense that it can be moved around. You don't have to have another program that accesses it. It's really kind of a protocol for accessing information in that file. So let's see. So I suspect that this is SQLite. And so now I'm going to look at these payloads for SQLite. That's SQLite. Where is it referenced? Extract table names, enumerating table name. Okay, so let me do this. Select table name and then to from. Got it. All right, so let's see if this works. What I'm going to copy here and select. So let's see, search. Okay, so what happened? What did I just do? Let me copy this all out and get so what did I paste? Why did it work? What did it do? Control V, Control U, V. And then let's see if SQL is a listed SQL. All right. So what do I have? I'm looking at this string here. So I feed in, this is our initial exploit where we just have our single tick. I have this union query and then what I Googled basically was the string, a way for you to run a structured query language instruction that says, give me the table name from SQLite master where table and table name are not like this. So when I referenced earlier a search, this percent sign is kind of like a wild card. It says if it starts with exactly SQLite underscore, underscore, basically anything, do not show that. That's what the negation of not like is. And then we follow it up with our same comment. Stop processing everything to the right of these comments. So the one thing I changed was because I knew that I had two columns that I had to fill space for. I said select one and the table name from the result of this query. So that's kind of what happened here. These are all attributes of a given row in the database. The type happens to be one. Table name happens to be one. Table is a value that's passed in. Now, there might be some scenarios where you have to juggle these quotes or you have to escape them because some secondary part of the query is just dependent upon them being in the right structure for some reason. Had this not been a string comparison, for instance, comparing like, for instance, an integer-based ID, then this injection might not have worked in the in this exact form. It might have had to manipulate it or massage it in some other way. But it worked, and so let's go back and look and see what else is there. So what information have we found out? We know that there's now a table called users. There's a table called sequels. There's a table called hidden table. So let's see. So what do I need to do? I need to paste this again. So I want to describe what am I trying to get? What information am I trying to get out of those? So I wonder if there's, well, I know there is. Let's look. We want to get the extract column names. So check this out. Copy. So let's look at ways we could do that. So this is a piece of SQL that will do just that. It will give me all the column names. Actually, get column names or from a given table. Okay, that's table name right here. So we know our table name is going to be one of the following. Where did we have? We had those three things. All right. All right, so hidden table, sequels, and users. So we're going to basically just kind of plug and play hidden table. And so we're going to have to do our same thing. We sort of abuse this one from select SQL from SQLite master where type not equal to meta and SQL not null and name equals hidden table. Oh, and then we have to tack on our comment at the end. Ignore everything. And it might be in some instances we don't have to add that. Let's see if that works. Okay, so what did that do for us? It says this command is going to return the SQL statement or SQL from the database table named SQLite master where the type is not meta. So that, again, type is just an attribute. Some of the rows on this table might have the type meta, some won't. So this is saying, I want to find all where the type is not meta and where the SQL creation statement is not empty, not null. and the name of the table is equal to hidden table. I picked hidden table one because it was at the top of the list and it sounds ominous, hidden table. So let's figure out what can we do to get that information. Well, we've kind of already done that. Now that I think about it. I can say union select flag text from hidden table intersect. So I'm gonna copy that right here. A V. No such column text. Oh, wait a second. All right, what I saw a second ago, let's go back. Boom. One more time. All right, so in SQL, what this was actually saying is not, there's not two columns there. It's giving the variable name and then the type, or the column name and then the type of that column. So this is the column name is flag and the type is its text. So where I did this, that is incorrect, right? So I just want to select flag from hidden table. I'm guessing. Let's see if I spoke prematurely. 3. All right, so it says selects. All right, so this is why I kept adding in that value a second ago. It's where I add in the number 1 to the front end of it. The error message that I was getting here, it says selects to the left and right of union do not have the same number of result columns. Again, it's trying to find the intersection, or not just the intersection, but all things that sort of fit the form. And so you have to have not only an entry in the gift column, but the child column. And in our second subquery, an entry in, the first position and in the second position. So let's go back one more time. So I'm saying union select the number 1 and then the current value of flag for every row in the hidden table. So let's see if that's same. Control A, V, enter, boom. All right, so it says gift 1, that's that 1 that we put into our database right here. And it says THM Fox, all I want for Christmas is you. This is, it looks like it's fitting the format of our flag, so I think that's it. We go back over here. Oops. Back to our puzzle. I'm gonna paste it. I'm gonna submit it. And that was it. Whoop, whoop. Our answer is correct. I think that's the entire task. Scroll up, keep scrolling. Keep scrolling. Yeah, sweet. We got our green check mark. We are done. I'm going to terminate that box and then move on to the next challenge. I might take like a quick bio break for a second. So we'll do that and we'll be back just a second. Okay. So that's the next challenge, the next web exploitation. So let's go ahead and hit deploy. Another cool thing about the advent of cyber is that they have someone else's videos of solving the task. So these are the creators of these challenges in a lot of instances, and just an excellent resource. Sort of call upon. So this one, it seems like it's referencing XSS, cross-site scripting. All right, so that's interesting. It's a very common vulnerability. It's talking about, gives an attacker the ability to not run code on someone else's server necessarily, but more on someone else's computer, their web browser itself, not on the website. Now, sometimes the way that they do that is going to abuse like what they call like stored cross-site scripting or reflected cross-site scripting. And that's what all of this stuff right here is kind of talking about. Stored means that it gets stored in the database on the website. So they're referencing right here comments. So if like you go to a website and you're allowed to leave a comment on a web page, that is an example of like a stored. But if it's a link that you click on and then you go to, maybe it's a really long link, you click on it and then it like takes you to a legitimate website, but then it somehow alters the look and feel of that website. That might be a reflected cross-site scripting attack. Okay. Right. So search query, keyword parameter, XSS exploited payload. Oh, here's our IP address. Boom. Copy to clipboard. Let's get in. We're done with that challenge. So boom, boom. Copy and paste. Oh, well, probably need a port, don't we? Well, I mean, we said that earlier. It's never a bad idea to run nmap and like figure out what other ports are available. This say 5,000. All right, so I'm gonna go here. 3. All right, we are back at Santa's portal. Make-A-Wish website, year 2020. Search query, ASDF. Showing all wishes. Test 1, 2, 3. Wish. All right, and then 1, 2, 3. Here are all wishes that have 1, 2, 3. Okay, so again, this is like that classic setup. Like I am able to control some input here. So I'm going to put in HTML code. HTML, again, just kind of what makes a website. So title, Santa's portal. Let's see if I can replace that. Oops. Copy. Right, so it didn't do anything to the page. You'll notice that nothing showed up. It didn't modify the title. I was curious if it would. But when I hit view page source, I should see a new, I do, bit of HTML. It's not just the test 1, 2, 3 I put in before. I now have this title ASDF. I was hoping that it would like take that top-down approach and like as it hit the new version of title, it would replace it. It didn't, but that's fine. Maybe not all browsers operate that way. Maybe some browsers that would work, some wouldn't. But what other kind of HTML can I put in there, right? So we said this was cross-site scripting. So this is going to be likely leveraging JavaScript. And so we could start adding in script tags. The classic example, and I think we even saw it flashed up a second ago, was, just popping in what they call pop an alert script. So I'm gonna hit wish, and you'll notice that all of a sudden on my screen I see this one pop up. Why did that happen? All right, so if I right click view page source again, I see not only the original test 123 I did, but title. And now I have, and again, this is valid HTML, it shows up, but I have this valid HTML showing up, which also happens to do something. In this instance, it says show an alert dialog with the value 1, right? And that's exactly what happened. So if I come back to the page and refresh, I'm going to cancel actually. Just enter. Every time I go to that page, I'm going to see the value 1 now sort of show up. 1 show up. And it happens because my web browser is doing exactly what it's told to do. It's getting the content of this web page and it's following orders top to bottom, left to right, following the instructions all along the way. And one of those instructions says show 1. So now that we've seen that, what are we supposed to even be doing? So let's see. And again, anywhere that you, the user, get to sort of control input, that is a potential vector for XSS, right? Or cross-site scripting. The more you know about HTML, the better position you're going to be in when it comes to like finding new clever ways to abuse like some of the mechanisms that are in place to sort of mitigate XSS. So you can see here they're giving you lots of good examples of, like, if you look again, kind of like we had that search parameter in the SQL injection, same thing. So here's another tool that they're using, how to detect XSS. Okay, and they're going to be using OWASP Zap. My understanding is it's similar to Burp Suite. It's a proxy, but it allows you to do additional kinds of checks and assessments. So let's see. All right, so here's our challenge. Okay. We did that. We have our address. All right, so our questions, we've done this part. It says, what vulnerability type was used to exploit the application? VRSORED. To exploit the application. I guess, what are they asking? Ready to read? What query string can be abused to craft the reflected XSS? Oh, okay. So there's more to this. So my search, if I go and type in yada yada query. Okay. All right. So when I search for ASDF, it's only going to show me. But again, like we said in the other one, Q query. Let's see if we can't do the same thing. Script alert 1. Script. Make it syntactically valid. Let's. Oh no, that was wrong. Dang it, that's not what I meant to do. All right, so go. All right, so again, I'm. What are we trying to do? We wanted to do scripts, alert 1, script, and then let's see what happens. Why did that happen? Here are all the wishes that have empty in them. I got 2 alert 1s. So let's see. All right, so when I type URL reflected in here, I see URL reflected, and I hit OK. That showed up. I didn't get 2 pop-ups because this time around it wasn't null, or it wasn't blank, if I understand correctly. So let's see. What were the questions it was asking? Let's go in here. What query string can be abused to create reflected? That query string, submit. It says, what vulnerability type was used to exploit the application? I don't know. Cross, no. Gosh, I'm thinking like, I don't know. I don't know what the answer they're asking, what they're expecting. So one nice thing about this is that it kind of gives you like the number of characters is required in the answer, and I don't see how it's fitting. So launch the Zap application. Let's try to just press and see what it maybe says. I'm gonna hit this. I'm gonna type in Zap. OWASP Zap. I'm gonna feed it this URL. See. Yes. No. So I'm gonna restart because I actually already have burp running, and so that error that I got was about you can't run 2 programs listening on the same port. So I don't have a whole lot of familiarity with that, so this will be a learning experience. All right. No, I don't really care about that. Next. Let's see. Bigger. So I think their instructions walked us through doing this with an automated scan. All right, on the right, you see a button saying automated scan. Let's do that. URL to attack is that. Oh, that's all right. It's actually going to be this. Copy, paste, equals. What else are they saying? Use traditional spider and hit attack. That's all you do, huh? Okay. Let's do that. Boom. Attack accessing URL. Okay. So what it's doing right now is, rather than going through and like manually finding all the ways that somebody might try to enumerate and like get different to bypass some protections. For instance, one thing you might do is anytime you see on the programmer side, the developer of the website, if someone tries to search for this word script like so, they might just remove that from the string and then replace it. That's a very common mitigation towards XSS, and you will stop a lot of like really low level, low skill attackers such as myself with tactics like that. But you'll notice that you see a bunch of like hexadecimal characters kind of coming through. I don't know if you've ever gone to a website and you see like %20 show up over and over again in something that you searched for. For instance, like this is what I am talking about. And enter. You'll see plus signs in between there. That %20 is the space sign, or the space, the character of a space. And that will, it's just another way to sort of help manifest that. Well, you can use other characters. So That 2b is the, I think, the less than symbol. That's what's wrapping the less than, the greater than symbol of what wrap HTML code. So what did it see here? It says cross-site scripting reflected and it found one, I guess. What does it do here? What are they asking us? Oh, okay, so this is the raw, like basic script they inject. It's kind of like a rendering of it. Let's see, do they have any more of a tutorial on Zap? I don't think so. I think that's it. It says you go to alerts, and it's supposed to be able to, everything you answer. So run a Zap, automated scan of the target. How many XSS alerts are in the scan? Alert 5? Is that what it says? Let's see. No. Submit. Nope, that's not right. Well, it only shows one right here. So let's go back, see. Submit. Uh-oh. What does this do? Alerts. I have 5 alerts. I'm not convinced I did this correctly. So one nice thing about OWASP, everything that they do is going to be, they're going to show you the problem, but they're also going to give you a way to address that problem, or mitigation for it. So that's what these solutions are in the references as well. So let's see, output, alerts, use of, I wonder if I was supposed to omit this part and see if that, I do that, did it find anything different? Okay, it's still running. Huh. Okay, so here's a whole room on TryHackMe, which is dedicated to like learning what this tool does and how it works. That's another great thing about this Advent of Cyber. Not only is this like a fun, like day-long lesson that you could do with them, but there's so much more that you can sort of pull from. So I don't know. I don't feel like this is going to yield the answer that I want either. Six. Okay. Okay. What's this say? Ooh. So good. I tried that already, I think. So good. 2. Is that the answer? So again, sort of getting frustrated that I don't know this. I can just like run through guess, but that's not really the point. So why did I pick two out of that? I started with one, or one was in there a second ago. Why did I see that? Well, I noticed that there was a persistent one that was there, that was not there before. This reflected one was, because this is what I fed it the first time, and this is what I fed it the second time. I took off the question mark Q, basically the query string. And it did not discover it again. Basically, it just, again, added the results of those two challenges together. So let's see. Basically, I mean, all I did was just add 1 and 1, got 2. There's that. So let's see, what else, what other questions were they asking? That's done. Are you able to make an alert appear on the Make-A-Wish website? We did that beforehand manually. What vulnerability type was used to exploit? So PERSISTENT. I don't know. What are they asking for? What vulnerability type? Cross-site scripting, persistent. I'm looking through like the text on here to see if okay, so let's go back. Get rid of this. Oh, wow. You can see that this is the evidence of all the stuff OWASP added in there. So all the various checks that they added trying to make something happen, whether that's something is like a callback from some other service which is going to read this information, or you know, like my web browser is going to look for it, or it's going to try to use SQL injection at the same time of doing it, like a cross-site scripting attack. Hmm. Hmm. They're trying here some like local file inclusion stuff, perhaps. Right. So I don't know. I really don't know what they're asking me to put in right here. What vulnerability type? Gosh. What's the hint say? Okay, we already got that, but I mean, that doesn't fit the format. Every other challenge, I'm just going to type it just to say that I'm positive that I typed it. Cross-site scripting. That's not right. So store, or actually persistent. I don't know. Gosh, that's frustrating. I hate that. It's a bad question, particularly on something that's not like, you know, there's not like a one and done like multiple choice. This is hard. We believe we understand the answer. I believe I understand the answer, but I don't know what to put it in. This is an example of a bad capture the flag question, right? So this is a question that is perfectly reasonable. It's just sort of shoehorned into the capture the flag paradigm, and that's frustrating for players. We got everything else going for us. We just don't know what the exact string you want us to type is. We have a good hint, but my mind's just not on that level right now. So let's see. 1, 2. let's look at that. I don't think it'll be susceptible to any of this. I want to see this. Answer format. The placeholder is this. I'm going to copy it. Order. That's wrong. That's not what I'm trying to do. I'm trying to go here. All right. So actually, no, I'm just gonna leave that. 1, 2, 3, 4, 5, 6. Oh, I gotta do that right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 10, 9. 6-letter word, 10-letter word, 9-letter word. Length. This is why I wasn't good at school, because like something like so I was driven to cheat, if you will, or at least find a workaround for this. So rather than find the answer, I'm going to find out like something about the test is revealing what the answer should be. So word lengths. What's a 6-letter word? What's the longest letter word that we found in here? That's going to be the one that's like a 10-letter word. That's not that common. So let's go back in here. Looking, so reflected. I'm in column 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so reflected is 9. So that's good. We know we used that to exploit the application. What else is persistent? P-E-R-S-I-S-T-E-N-T. That's 10. What else is there? Stored, persistent, reflected. Is that what they're asking for? That's 6. Okay, so let's try that. That's frustrating. Oh, that's so frustrating. Okay. That wasn't the answer. Did I misspell anything? What's the question? Is it asking me something weird? What vulnerability type? Okay. Select the application. I'm like, this is terrible. It's a terrible question. Hate it. So much so that I'm just gonna I'm gonna let that run for a while and just think about it. And this new one, this new challenge, this is today's challenge. We were playing the last couple of days challenges. What happened? Okay. Oops. Go back. All right, and then I need to get those onto my Kali machine. So let's do this. Oops, wrong one. Loads AFC. See. All right, so all I'm doing here is I copied the file over from one computer. I'm onto my virtual machine. Let's see, pcap one. Actually, let's do. I want to move all my pcaps into pcaps folder. All right, so I have 3 pcaps in there. Verify that they're in various sizes. One's 3 megs, the second one is 35K, and the last one is 600K. Okay, so we've given up on this other challenge. It's frustrating as that one is. Okay, hold on. Reflected. Ooh, wait a second. Reflect. Yeah, is that what I typed? 9 selected, 10 selected, 6 selected, 6, 10, 9. That's killing me. So I went 9, 10, 6. Ugh. Yeah. Okay. Okay. Just press on. All right. Let's look at this. So Wireshark, it looks like was the tool they mentioned at the very top of this. Man, they give you a lot of backstory on like even what is an IP address. This will be a great resource, like introduce some concepts. So they're saying it's 6 a.m. Elf McSkitty, clocking into the best specimen companies, stock headquarters. Eager. Uh-oh. So data exfiltration determined here. It's time for the ever-vigilant Elf McEager to prove his salt and find out exactly what happened. Unknowingly, McSkitty made this all up. This is a real attack and a training exercise. Way ahead of Elf McEager's performance review. Excellent. All right, so we're going to learn what an IP address is. We're going to learn about TCP/IP, stack, and UDP, as well as a 3-way handshake with TCP. We're going to get a crash course in Wireshark. We're going to start analyzing PCAPs, and then we have a challenge at the very end. I'm just going to jump down to the very end of the challenge, because we're going to learn all that stuff as we go. So it says download the zip. It says open PCAP. What is the IP address that initiates the ICMP? Okay. All right, so here we are in our analysis machine. We can fire up Wireshark by going to the start. Wireshark. So you have to, because you're doing weird stuff potentially with the network interface card. When I say weird stuff, I mean like putting it into what they call promiscuous mode or sniffing mode, if you will. You have to do that as an administrator or as root. So Kali, default creds. All right, so here, just like every other program, you hit the open folder, computer. This is the tricky part. Hit home, Kali. This is where the files are actually on my thing. So I have to go to the computer, and it's like going to the C drive. There's a home folder, which is like on Windows, you would have C users. Then you have a list of users that exist, Kali. Then we have, remember that folder I made earlier? I have PCAPs in. There it is. I'm going to open the first one. Why did I open the first one? Oh, it told me to. It said pcap1.pcap and Wireshark. What is the IP address that initiates the ICMP ping? So ICMP is the Internet Control Message Protocol, something like that. And is there a way to zoom in on this? There is. Sweet. Scale up, over, 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 over. So a couple things to note here. is that first, this time column is deceptive. Really, what that represents is the time since the beginning of this capture. So this means at 0.0000 seconds after the start of the capture of this data, this packet was encountered. This one happened 0.000082 seconds after the start of this packet, right? Or of this packet capture. If we look at this one right here, this one happened 3.5 seconds after the start of the capture, right? If we keep scrolling down, time is an arrow. So this happened 63.98 seconds into this. And so what this represents is the sum of, in some instances, depending on how this information was captured, all of the traffic that is either coming from a machine or at least the majority of the traffic that's coming from a machine. There's some things that have to do with, like, for instance, like dropping packets. If a device is overwhelmed or kind of running at its wit's end, it may not be able to process all of them. So it might actually prioritize sending the packet before it prioritizes drop, like saving the packet to a file, that PCAP file. So it really just depends, but by and large, I think it's not unreasonable to say this is the largest majority of the traffic leaving a computer or traversing a network. So the question was, there's a couple of things here to note, right? What I'm sort of scrolling through, this is the packet, like, I think it's they call it the packet summary pane, or where all the bulk of, like, where you're going to be scrolling through, right? So down here, you actually have your details pane, and then this is the important bar here. It says the apply a display filter, like kind of in the background, it's subdued. This is where you can actually sort of start carving up information. So they asked about ICMP. They said we're going to learn about TCP and UDP as well. But if you scroll down, you can start seeing other protocols in one of these columns. What I just did was I clicked on them, just like in Excel. Each one of these rows has columns, and these columns store information. Now, as I click on them, I can sort them in ascending or descending mode. That's useful sometimes. Like if you want to see the largest instance of communication in terms of how many bytes are sent from direction A to direction B, you can sort on this column. But be mindful about this column, this first column. It's called no or number. This is the packet number. This is the order in which they are received. So you can almost use this, or you can use it as chronological order. Same thing for time. So we can sort these columns based on the source IP address. So if you wanted to find information and sort of group all of the same IP addresses together, to sort of get a summary view of, like, okay, well, this 10.10.15.52 address is talking to not only this 10.11 address, but this 91.189 address. It's also talking to, well, I guess the same IP addresses again. An 84 and an 85, 92 and a 41. So, I mean, there's ways and reasons that you might want to group them. In that way, you can group them by protocol. Say I want to look at all the ICMP traffic together. I can do that. I can look at all the NTP or network time protocol, likely. Yeah. I can view all of that stuff together in the same, like, sort of general region, but just bear in mind that it may not have happened chronologically in that order. So if you want to get back to that flow of events, this had to say that this person started talking at this time, which is before some other time. Make sure you sort it chronologically. So scroll down. And the other way to look at that is, like, there's a little tiny arrow you might be able to get right here. Yeah, this little tiny arrow pointing upwards or downwards. So that's going to be ascending or descending. Yeah. So All right, so the question was, what is the IP address that initiates the ICMP ping? So I mentioned this display filter. I can type in ICMP, and that's going to not show. It's not going to remove anything. It's just going to hide or filter out all of the traffic which does not match this filter. Another way to read that is that it only shows what does match this filter. So because it does match ICMP for the protocol, it will show up. So we can look at these and know that they're in chronological order because it's sorted in descending mode right now, time-wise. And the question was, what IP address initiated the ICMP? There's a couple of things to understand about ICMP, particularly what we call ping. We say ping all the time. There's a couple of parts to it. There's the request and then the reply. If you ever ping something, you don't get a request that says so-and-so timed out, that's you're failing to get a reply, right? You're sending requests, but you're not getting replies. So it says that 10.11.3.2 tried to initiate a request to 10.10.15.52. Am I right on that? Yeah, 10.11.3.2 initiates 11.3.2. We submit that. It says we got that correct. Good. It says we only want to see HTTP GET requests in our PCAP1. What filter would we use? All right, so I showed that ICMP right here. There's other protocols, and so that you can filter on. Right, so if I back this out and hit enter, it's going to show me all the protocols. I can sort on these protocols. I can look for TCP, NTP, HTTP, ARP, ARP. So this is only showing me address resolution protocol. If I look for NTP, it's only showing me NTP. If I type HTTP, it's only showing HTTP. So what's interesting about some of these protocols, and I guess really about all networking protocols, is that they exist somewhere in a hierarchy. There is this thing, the OSI model, and these protocols operate at some layer of that OSI model. For instance, ARP operates at, I think, layer 2 of the OSI model. It is a very low level mechanism used to communicate information. It requires a lot of understanding about how the computers work, right? It's more computer or communication oriented than it is person oriented or human oriented. Whereas HTTP operates kind of layer 7, which is the highest layer. So it, well, I guess maybe it's not layer 7, and it itself is a protocol that you can use to have other applications stacked on top. So maybe it's not layer 7, but the point being is that there are ways that you can encapsulate information, sort of like a Matryoshka doll or those Russian nesting dolls. HTTP is one mechanism that you would use for that. So, and it has these things called methods. And I think when we look at the try-hack-me, if we look here, I think they probably are going to give us a resource. Yeah, a rough breakdown of like, hey, here are some, just like in our computer programming stuff, if we want to find things that are equal, if they're not equal, or if we want to use like logical conditions, like this condition and this condition must be true in order for it to show up in the display filter. So let's see here. So there are attributes to each one of those filters. So there are attributes. If I hit the period, it's kind of like accessing a class in Java or attribute for a class in Java. I'll say, object dot some attribute. One of the attributes that I want to look for is the method, because they're asking for the GET request. And GET is a HTTP verb that they use. So if I type http.method or, hey, gosh, request method. Let's see, what does it do? This is one of the things that this is syntactically valid. It just doesn't do what I want it to do as a programmer. So they have this thing. Let me go back to HTTP, right click, and I want to, if I get my expression builder. That's not what I wanted to do. I want to view expression. How do I get that? I don't even know how to do it. What are they saying to me? Well, I was going to try basically, oh, okay, protocol.request method, http.request.get or http.request. And I think that's looking funny because I'm zoomed in. Okay, so http.request.get. Did that work? I thought I tried it a second ago. I don't think so. So let's follow the tutorial. Let's read the instructions. Show all packets to the specific line. For example, HTTP allows for both get and press the data accordingly. So what's really cool is ICP and IP.source, IP.dest. You can say, I only want to see packets where the source is equal to an IP address that you're explicitly trying to search for. So let's see here. HTTP. I know that this is a GET request. I want to apply a filter. Why is that? Okay. Let's see. Selected. Oh, no. Go. I don't know why I can't apply this filter, follow. Man, all right, let's see. What is it telling me? It should be this. http.request.get. Are they giving you any objects? What is it saying? What's the question? So we only want to see GET requests. Request.get equals GET. Method equals GET. I'm pretty sure that's what I did, something akin to that. HTTP request dot method get. Here we are. Here's our expression builder. I don't know what I did to get it. I think I right-clicked it. Whatever. HTTP dot, and it'll show you basically all of the options beneath it. HTTP. I want to find request. What was it? Request.method equals value. Oh, why is this not working? So if it's red, it's syntactically invalid. There's one you have to watch out. If it's yellow, it's syntactically valid, but it's known to not necessarily be what you intend it to be. I don't know why this isn't yielding the results I expect. So what I'm gonna do is Wireshark show only HTTP GET. And hopefully there'll be a display filter. I don't understand. This filtering by HTTP method. So what's the internet have to say? Your mileage may vary. HTTP request dot method equals get. That's what we had, is it not? Oh gosh. It is case sensitive, so mind that. Let's see. Let's get our answer. Submit. What's our hint say? We've demonstrated filtering web server within the task. Okay, well, there's that. I'll apply this for the one. What is the name of the article at the IP address? This. Okay, so this is an opportunity for use that IP dest. We know that this IP is what we're looking for. IP dot dst equals that. So let's see if that's that yields what we want. Request method equals get. It didn't, certainly didn't. Okay, so there's one that's useful. I'm gonna undo all the things that I just did, hopefully. And IP.adder. This gets it at, this sets it up such that whatever IP address you feed it will either be the source or a destination, it doesn't matter. As long as it occurs in the communication, it should show it. And it's, what's the question it's asking? It says, what is the name of the article that the IP address so-and-so visited? Okay, so this is actually the source. So the source is making a request to, or a GET request to some. So we actually don't want this. We want source. Our source is this, and it's asking for a request. And all right, so here's another interesting trick. If we right click follow HTTP stream, this is kind of a way for you to, it reassembles all of those packets and it kind of gives you the textual representation of a website. That is to say, the source of the website. HTTP is a plain text, like human-oriented like protocol. So everything that you see, like you see the word GET, that is actually what the computer sends to the server, and the server replies HTTP/1.1 200 OK, you know, depending on whether or not it was a valid request or not. So we can see here that somebody opened up a website in their browser, and they went to the slash of a web page. So they went to, it looks like tbfc.blog. You know, that was the end of, that's what the website is. And that runs all the way over here. The server says, okay, here's your information. They feed it to them. There's a bunch of information. Everything in blue is a response from the server. Everything in red is a request made from the client. So all this blob right here is actually just part of the infrastructure made to serve up the website. rest of that, I want to see all of it. Okay. So what's the question they asked? What is the name of the article this person visited? So that's one flow. Let's see. We can see all of it. Oops. IP dot C equals oh, and also I want you can see that all of these things are kind of mixed in together. And so I'm going to filter out all the TCP. So HTTP lives on top of TCP. So if I'm looking for just the IP address, it's going to show me the results. And it might be that there's overlap between the two in how the protocol is interpreted. And HTTP dot request method. So this should show me everywhere where this person is, or this source made a GET request. Everything. So I'm looking for the title of an article. I see post reindeer of the week. Right click, follow HTTP stream. And so all we're looking at right here, this is the actual, apparently there's an image that's requested in this website for some reason. Well, not for some reason. I mean, that's websites host images. So I want to see this. So this is another way that I'm viewing. I'm viewing all, you can see that everything's in red, so it's everything the client is sending. So I'm going to copy this right here. This looks like a blog post, and everything else is just supporting infrastructure to it, it seems. Try Hackney. Did that get it? Nope. No, I don't think that did it either. The week. Nope. Hmm. So I go back to here. It says name of the article. At the very end. So it's funny, there's a bunch of like not like 404, like not found for it. So it makes a request where the refer is, I can't find all of these fonts. The name of the article, okay. So here's the final HTML for the page. And we can see the word article show up, but that's just an HTML tag. So let's look for the title. Is it Reindeer of the Week? copy. Ugh, kill me. It's one of those things where you gotta press through and find it, I guess. I feel like it would show the slash characters. So let's do this. Another trick, I think they show this in the output. You can go to export objects, HTTP objects. I want to find everything. Reindeer of the week. I'm going to save all. Computer, Cali, pcaps, new folder, pcap 1. Choose. All right, so they should exist in a folder now. So if I go to view folders, folder, pcaps. So let's find an reindeer of the week HTML document. Click it. Yes, I don't know. Just like the shout out, Reindeer Rufus, but Reindeer Rufus only managed to knock over 3 elves this week. We can be a great role model for other reindeers. Keep it up. The internal blog. Is that what they were looking for? I don't think so. I think everything would be separated with spaces. God dang it, man. Like, all right. Hold this. What's the hint say? /post reindeer of the week. I thought I pasted that in there. Oh, did I hit the wrong one? Surely not. Surely I haven't been putting it in the wrong one this whole time. It's frustrating. Computers are hard, y'all. All right, so on to PCAP 2. Let's look at the captured FTP traffic. The password was leaked during the login process. There's a lot of relevant data here. Using a filter would be useful. All right, so let's open it, get a sense for what PCAP 2 is. All right, so it says that. Let's sort it chronologically, of course, in descending. So the oldest items happen at the top, and we move forward in time by scrolling down. So first things first, we see the first, we're like in the middle of an SSH connection. We see some TCP, we see FTP, that's interesting. We see request quit, response goodbye. It says, welcome to the FTP server. So somebody logged out of the FTP server, or at least their client was like logged out. So maybe the client restarted, maybe they were done downloading the file, they're about to start downloading a new file, because we see a disconnect, or rather a quit, and then a new order of connections. So it says here's this. So why do we see the word welcome to TFTP server? Well, again, FTP is an unencrypted communication mode, right? So it's a protocol that does not have any inherent encryption like built into the protocol. So that means that anything, if we're in a position where we can capture the traffic, like we would be in line with the client computer, and like say we're the router or the firewall. This is a lot of times where packet captures will happen is at the firewall. We're able to witness that communication take place. Therefore, we can sniff it and save these packets. So we can see the username that's being sent across. All right, and once the client makes that request, says, "Hey, I am user Elf McSkitty." The server says, "We accept that user. What is the password for that user? Please specify the password." The client then says, "All right, well, here's the password." Preface with PASS, and then it says plain text pass fiasco. So I think I'm going to right click, and then you can copy just the value. Yeah, that got us the answer. It says continuing with our analysis of PCAP2, what is the protocol that is encrypted? Let's keep looking around just to see if there's anything else here. SSH. And we keep seeing these things where it says encrypted packet, encrypted packet. SSH stands for secure shell. It's secure because it's encrypted. So I think that's going to be the answer to that question, just for the sake of seeing anything else. Didn't see anything else. So it's 3 letters. Another one of those 3-letter acronyms could have been like TLS or SSL, but we don't see any of that here. So SSH was the right answer. And Recover Christmas. What is on Elf McSkitty's wish list that can be used to replace Elf McEager? Okay. So let's open PCAP 3. Let's see. We get this little mini map as well. And so again, it's not that there could be hundreds of different source and destination like instances of communication that are taking place right here. So we don't know exactly what we're getting into every time we open it up. But this gives us a good sort of starting point, as a lot of these things are color coded. HTTP, I think, by default is green. So if you see a bunch of green, you're likely looking at something that you can inspect with a little more certainty that you'll be able to see something inside of it. So basically, what I might do is type exclamation SSH, because I can't, it's encrypted. I don't have a key to decrypt it, so I want to hide it. So let's show everything that's not SSH. And that sort of cuts down some of that irrelevant data. That's what so much of this analysis game is being able to find out what information is one, observable, and relatively useful to you. So just by doing that, I was able to scroll down a little bit, and just by happenstance, I saw get/christmas.zip. Because it's HTTP, a zip file is an interesting file. It stores other files. There might be something of value inside of that. That's just metagaming on the CTF. Like I know that they're likely, and I think the challenge said it's like, oh, what is on Elf McSkitty's wish list, right? Okay, well, that seems interesting. It seems juicy. I'm gonna go to file. Hopefully, I'm gonna go to file. Maybe I will. Let's see. Alt F. And then I can go to export objects, HTTP. And again, earlier I said save all. I can kind of be picky about it. I can just hit save, and it will give me the option to just save the one file that I have highlighted, or the multiple files I might have highlighted. So I'm going to PCAPs, Christmas.zip. All right, as I hit OK, it basically exits out of there. I'm gonna go back to my home folder, go back into PCAPs, Christmas.zip, and I can just double click it and it should open up. And it's interesting, there's Elf McSkitty's wish list. So let's go ahead and take all of these files, extract them. Let's see, new folder, unzip. All right, so let's look at them. What were those pictures? All right, that's a cool background. Is there anything else? Christmas tree.jpg. Okay. Operation Arctic Storm. Interesting. It's a confidential work document for Santa's elves. All right. What's that? This. Strictly confidential. Chris Kringle wrote it November 14th. It's only one page though. Interesting. There's a selfie, Bull St. Nick, and then our wish list. Ah, why is this taking forever? Here. So we want 3 Hack 5 pineapples and 1 rubber ducky to replace Elf McEager. So the rubber ducky is replacing Elf McEager. R-U-B, let's see, R-U-B-B-E-R. All right. Oh, that was the networking forensics challenges. Those are cool. This will be a cool introduction for folks. Follow along. This will be a great, like, communication is like interesting things live on other people's computers, and understanding how protocol works, understanding what is happening when you open your web browser. It's essential to sort of like opening the gates of like what you can do with computers, like understanding how that process takes place. Really is an amplifier of one's ability to participate in like the global network. I mean, it's how it happens. So let's spend the remainder of this time trying to figure out what they're asking on this challenge. They're asking for what vulnerability type was used. What vulnerability type was used to exploit the application? I might have to give up. Actually, it's not even really giving up. Check this out. I'm gonna watch this. Here's I think somebody had a solution video that they posted. Watch Dark Star's video on solving this task. It's a YouTube video. All right. Let's see. I think they're walking you through the solution portion. I think. Ah, oh, dang it. All right. So the vulnerability type was stored cross-site scripting. Well, there's our answer. So let's go here, here. What am I doing? So what was my trick earlier? I was looking at this. There's this. Okay. Those are the, like, stored and persistent are kind of synonyms for like XSS, but it was stored cross site. thing. Yeah, same link. That's unfortunate. I don't like that. That was kind of lame. Let's see, where'd it go? Submit. Oops, I still got it wrong. How to do that? What? How did I still manage to get it wrong? What? All right, I cheated and I still got the wrong answer. That's craziness. Oh, no, it eventually went. Okay. All right, so that brings us to a conclusion, man. Sometimes that's just what you'll run into. Little details catch you up. So, all right, well, we're going to try to continue on the rest of the week doing some more of these challenges, at least one a day. So, all right, good luck. Enjoy the rest of the challenges.